Picture this: a corner of the universe where up is down, left is right, and the rules of reality, as we know them, simply unravel. Places where gravity doesn't pull but pushes, where time doesn't march forward but loops like a broken record, and where matter doesn't just exist, it flickers in and out of dimensions like a candle in the wind. These aren't scenes from a sci-fi movie. They're real, documented cosmic anomalies scattered across the vast expanse of deep space, and they're rewriting the textbooks of physics, one mind-bending discovery at a time. Welcome to the 24 unstable realms in deep space where physics turns inside out, a journey into the universe's most baffling, beautiful, and downright terrifying corners. Think about everything you've ever learned about how the cosmos works: the steady pull of gravity, the unshakable speed of light, the predictable decay of matter over time. Now imagine all of it flipped on its head. Out there, in the infinite black, there are regions where particles teleport like ghosts, where black holes spit out matter instead of swallowing it, and where entire galaxies behave as if they're trapped in a cosmic funhouse mirror. These aren't just quirks of nature, they're screaming clues that our understanding of reality might be just the tip of the iceberg. Scientists call them anomalies, but they feel more like messages, whispers from a universe far stranger than we ever dared to dream. So why should you care? Because these realms aren't just distant curiosities, they're windows into the deepest mysteries of existence. They challenge us to ask, what if the laws of physics aren't universal? What if time, space, and matter are just suggestions, from quantum vortices that might bridge parallel dimensions to celestial storms where antimatter rages like a tempest? Each of these 24 realms is a puzzle waiting to be solved. And as we explore them together, you'll start to see the cosmos not as a static backdrop of stars, but as a living, breathing enigma, one that's still evolving, still surprising us, and still hiding secrets we've only begun to uncover. Strap in. By the end of this journey, you'll never look at the night sky the same way again. Deep in the heart of galaxy NGC 1277, reality itself seems to glitch. This isn't just some cosmic whirlpool, it's a quantum vortex where the rules of physics don't just bend, they shatter. Picture electrons vanishing from one spot and reappearing light years away, as if space itself has secret backdoors. Or particles that don't just exist in one state, but in countless possibilities at once, like a cosmic coin forever suspended mid-flip. What makes this place truly mind-blowing isn't just the chaos, it's the eerie, luminous haze that pulses from its core, a glow that's been puzzling astronomers since the day they first spotted it. Some researchers think this vortex might be more than a freak of nature. It could be a cosmic crossroads where parallel dimensions brush against our own. Imagine two soap bubbles touching. For a fleeting moment, their surfaces merge. That's what might be happening here, but on a scale that warps the fabric of reality. The math behind it suggests particles aren't just teleporting, they're slipping through cracks between worlds, hinting at a multiverse we can't yet see. And that ghostly glow, it might be the energy of those collisions, a beacon from realms beyond our own. But here's the real kicker. This vortex challenges everything we thought we knew about quantum mechanics. Back on Earth, quantum weirdness happens on tiny scales. Think lab experiments with single atoms. Yet here, it's playing out across light years, as if the universe hit fast forward on quantum chaos. It's like discovering a single drop of water that defies gravity, only to realize there's an entire ocean behaving the same way. Could this be nature's way of showing us we've only scratched the surface of physics? Or is NGC 1277 a cosmic outlier, a glitch in the system we'll never fully explain? One thing's certain, the deeper we look, the more questions we find. Near the frenetic spin of Pulsar PSRJ 1748-2446 AD, time doesn't just slow down, it staggers, warped by gravitational forces so intense they twist spacetime into knots. Picture a clock ticking in this abyss. Its hands would drag as if moving through syrup, marking seconds that stretch into what feels like minutes. An astronaut orbiting this cosmic whirlpool might return to Earth to find their peers aged decades while they've barely lived a year. This isn't science fiction, it's Einstein's theory of relativity pushed to its breaking point, where gravity doesn't just bend light, it crumples the very fabric of existence. What makes this realm so extraordinary isn't just the time dilation, it's the pulsar itself, a neutron star spinning over 700 times per second. That's faster than a kitchen blender, compacted into an object denser than Mount Everest squeezed into a sugar cube. At these speeds, the star's gravity becomes a cosmic funhouse mirror, distorting reality so severely that time itself fractures. Scientists call it frame dragging. The pulsar's rotation literally pulls spacetime along with it, like a spoon swirling honey, creating a vortex where the laws of cause and effect blur. Could this be the universe's way of hinting at time travel? The math suggests that passing through this abyss might allow for closed time-like curves, loops where an object could theoretically revisit its own past. But there's a catch. The tidal forces here would shred anything made of ordinary matter long before it could exploit the effect. It's like finding a door to yesterday, only to realize it's guarded by a black hole's worth of gravitational fury. Some physicists argue this isn't a gateway but a trap, a natural no from the cosmos to prevent paradoxes that could unravel reality. Yet the mystery deepens when we consider the pulsar's twin beams of radiation, which sweep across space like a lighthouse from hell. These jets aren't just energetic, they're encoded with data about spacetime's behavior under extreme conditions. By studying them, researchers have glimpsed anomalies that challenge even Einstein's equations, like moments when time seems to stutter, as if the universe itself hit pause. Is this a clue to a grander theory of physics, one that unites quantum mechanics and gravity, or just a reminder that some corners of the cosmos weren't meant to be understood? One thing's certain, PSRJ 1748-2446 AD isn't just a laboratory for relativity, it's a cosmic question mark. Every flicker of its radiation, every twist of its gravitational field whispers the same tantalizing riddle. Are the laws of physics as immutable as we think, or are they just placeholders for truths we've yet to uncover? At the heart of IC 1101, the largest galaxy ever discovered, a storm of pure annihilation rages, an unfathomable tempest where antimatter doesn't just exist, it dominates. Picture a cosmic thunderhead crackling with energy, but instead of rain, it unleashes particles that obliterate normal matter on contact, transforming entire suns into blinding flashes of gamma rays. These aren't just explosions, they're the universe's most violent conversion events, where matter and antimatter cancel each other out in bursts so luminous they briefly outshine the galaxy itself. What makes this phenomenon so baffling isn't just its scale, it's the sheer improbability of it. Antimatter is notoriously rare in our universe. For every billion particles of matter, only a handful of antiparticles exist. Yet here, in this turbulent realm, that ratio flips upside down. It's like stumbling upon a desert where water spontaneously bursts into flames. The storm's core churns with positrons and antiprotons, swirling in densities that defy all known physics, as if nature's rulebook has been tossed aside. Scientists are locked in a debate over its origins. One camp argues this could be the fallout of a collision between parallel universes, a cosmic fender bender where our universe scraped against a neighboring one made entirely of antimatter. The resulting shockwave might have seeded IC 1101 with this exotic fallout, like debris from an interdimensional wreck. Others point to dark energy, the mysterious force accelerating the universe's expansion. Could this antimatter storm be a side effect of dark energy interacting with spacetime itself, twisting the vacuum of space into a particle factory gone rogue? Then there's the sheer power of these annihilation bursts. When a single gram of antimatter meets matter, it releases energy comparable to a nuclear bomb. Now imagine that happening on the scale of solar systems repeatedly, violently, without warning. Telescopes have detected gamma-ray flashes from this region so intense they've temporarily blinded instruments designed to study supernova. It's as if the galaxy has a hidden particle accelerator, one that operates without magnets or chambers, fueled purely by cosmic chaos. Yet the storm's most unsettling feature might be its longevity. Normally, antimatter vanishes almost instantly, annihilating upon contact with matter. But this tempest has persisted for millions of years, suggesting something, or someone, is continuously replenishing it. Could there be an undiscovered process, a loophole in quantum physics that generates antimatter naturally? Or are we witnessing the aftermath of an ancient, unfathomable event, a wound in reality that never fully healed? One theory even suggests the storm isn't destructive at all, it might be creative. Some models show that the energy released by these annihilations could trigger star formation in surrounding clouds of gas, like a cosmic phoenix rising from its own ashes. If true, this antimatter maelstrom could be both destroyer and architect, sculpting new worlds even as it erases others. The enigma of IC 1101 forces us to confront a humbling truth. For all our equations and experiments, we've barely scratched the surface of how matter and antimatter behaves under extreme conditions. This isn't just a laboratory for particle physics. It's a cosmic courtroom where the fundamental laws of nature are being challenged. Every gamma-ray flash, every anomalous particle detection whispers the same unsettling question. What if antimatter isn't the rare, fragile thing we thought? What if, in the right conditions, it's the universe's default state? At the center of Messier 87, one of the most massive galaxies ever observed, the unthinkable happens. Gravity doesn't pull objects down, it pushes them away. Picture tossing a rock into the air, only to watch it accelerate upward forever, as if Earth's gravity had suddenly repelled it instead of attracting it. That's the mind-bending reality of this cosmic anomaly, where the fundamental force we take for granted flips its script. Even light doesn't escape unscathed. It bends in jagged, nonsensical paths like a reflection in a shattered mirror. The culprit, a supermassive black hole so powerful it doesn't just warp space-time, it twists it inside out. What makes this phenomenon so extraordinary isn't just the inverted gravity, it's the scale. Most gravitational oddities occur on the quantum level or near theoretical constructs like wormholes. But here, an entire region of space, spanning thousands of light years, behaves as if the universe's rulebook has been rewritten. Stars near the galaxy's core don't orbit the black hole, they're repelled by it, drifting outward like leaves caught in a cosmic updraft. Gas clouds that should be devoured instead spiral away, as if the black hole itself has become a gravitational repellent. The leading theory points to the black hole's incomprehensible spin. Rotating at nearly the speed of light, it drags space-time around it so violently that the fabric of reality knots itself into paradoxical shapes. Imagine stirring a cup of tea so fast that the liquid climbs the sides instead of sinking to the center. That's the kind of chaotic motion happening here, but with space-time itself. Under these extreme conditions, the equations of general relativity suggest gravity could effectively reverse, creating a zone where down becomes up. Yet there's a haunting possibility. This might not be an anomaly at all. Some physicists speculate that Messier 87 offers a glimpse into a mirror universe where gravity operates oppositely by default. In such a reality, black holes might repel rather than attract, and the cosmic expansion we observe could be contraction viewed from the other side. It's a radical idea, but the behavior of matter in this zone eerily aligns with certain untested predictions of string theory, where alternate physics govern parallel branes of existence. The implications are staggering. If gravity can invert here, what stops it from happening elsewhere? Could pockets of reversed physics exist throughout the cosmos, hidden in plain sight, even more unsettling? If we could survive the tidal forces near this black hole, would we perceive ourselves as falling up, or would our brains reinterpret the universe to make down still feel like down? Reality, it seems, is far more malleable than we ever imagined. Messier 87 gravity reversal zone doesn't just challenge our understanding of black holes, it forces us to confront the unnerving idea that the laws of physics might be local, not universal. What we call gravity could be just one variation in an infinite spectrum of possibilities, a single note in a cosmic symphony still waiting to be heard. Barnard 68 isn't just a dark nebula, it's a cosmic vanishing act. Stare into this region of space, and you'll find a perfect circle of emptiness, a hole punched through the starry backdrop as if someone took an eraser to the universe. Unlike typical nebulae that glow with reflected starlight or cradle newborn stars, this one devours light whole. Photons enter but never exit, leaving telescopes to capture nothing but an abyss so absolute it feels less like an object and more like a glitch in reality itself. What makes this nebula so unsettling isn't just its darkness, it's the way it defies the laws of electromagnetism. Normally, even the densest clouds of dust and gas merely dim or scatter light, like fog softening a street lamp's glow. But Barnard 68 absorbs every wavelength, from radio waves to X-rays, with a hunger that suggests something far stranger at work. Some theorists propose this isn't just a dust cloud but a region where the electromagnetic force, the same force that binds atoms and lets your eyes see these words partially shuts down. Imagine a room where sound doesn't echo, flames don't flicker, and magnets lose their pull. That's the eerie silence reigning here. Then there's the nebula's uncanny structure. Most cosmic clouds are irregular, shaped by turbulence and stellar winds. But Barnard 68 is a near-perfect sphere, its edges razor-sharp, as if sculpted by an unseen hand. Infrared observations reveal its interior isn't just cold, it's a frigid -260 degrees Celsius, just a hair's breadth above absolute zero. At these temperatures, molecules should freeze solid, yet the nebula's gases move with a slow, eerie coherence, like a single organism breathing in the void. Theories about what lies behind this curtain of darkness range from the plausible to the profound. One camp argues it's a nursery for a future star, so dense that not even light can escape its gravitational pull, a protostar in the making, hidden from view. Others suggest it's a knot of dark matter, the invisible stuff that makes up most of the universe's mass, finally revealing itself through its interaction with light. But the most radical idea, that Barnard 68 is a cosmic defect, a scar left over from the Big Bang where the fabric of spacetime never fully smoothed out. In this scenario, the nebula isn't just absorbing light, it's funneling it into a dimension we can't perceive, a cosmic drain spiraling into the unknown. Yet the nebula's greatest mystery might be its impermanence. Measurements show it's collapsing, and within the next 100,000 years, a blink in cosmic time it could ignite into a star. Until then, it stands as a haunting reminder of how much we still don't understand. Is this darkness a cradle for new creation, a window into hidden physics, or simply a void that refuses to be filled? The answer, much like the light that enters Barnard 68, remains tantalizingly out of reach. Deep in the heart of the able 2744 galaxy cluster, something impossible is happening. Time itself seems to be running backward. Not in the way we imagine rewinding a tape, but in a far more profound sense. Entropy, the universe's relentless march toward disorder, is reversing. Heat flows from cold objects to hot ones. Shattered galaxies reassemble themselves. Chaos spontaneously transforms into order, as if the cosmos has forgotten its own rules. This isn't just a violation of the second law of thermodynamics, it's a full-scale rebellion against one of physics' most sacred principles, and it's forcing scientists to question whether we've misunderstood reality itself. What makes this phenomenon so unsettling is its sheer defiance of everything we know about energy and decay. Normally, entropy is the universe's one-way street, an irreversible process that explains why ice melts, buildings crumble, and stars eventually burn out. Yet here, in this cluster of hundreds of galaxies, the opposite occurs. Gas clouds that should be dissipating instead coalesce into intricate structures. Radiation that ought to scatter randomly instead organizes into coherent patterns, like a shattered pane of glass reassembling itself mid-fall. Even the cosmic microwave background, the afterglow of the Big Bang, shows strange ripples in this region, as if time's arrow has flipped direction. The leading theory involves dark energy, but not the kind we're familiar with. Most models treat dark energy as a uniform force accelerating the universe's expansion. Yet in Able 2744, researchers speculate it might behave more like a cosmic sculptor, locally rewiring the laws of physics to create pockets of anti-entropy. Imagine a river flowing uphill not because of some external pump, but because the very concept of down has changed. That's the scale of rearrangement we're talking about. Some equations even suggest this could be the work of a higher dimensional force, a shadow of physics from beyond our four-dimensional spacetime. Then there's the eerie synchronization of these effects. Galaxies separated by millions of light-years exhibit the same entropy reversal simultaneously, as if connected by an invisible network. This has led to wilder hypotheses, like the cluster sitting at the intersection of cosmic brains, membranes of reality predicted by string theory, where different universes brush against one another. In such a scenario, energy might be leaking in from a dimension where time flows backward, temporarily overwriting our own laws. It's a radical idea, but the math intriguingly aligns with the observations. Yet the most haunting implication isn't just about physics, it's about fate. If entropy can reverse here, could it happen elsewhere? Is our universe's eventual heat death, a cold, lifeless equilibrium, truly inevitable, or just the most probable outcome in a cosmic dice roll? Able 2744 stands as a humbling reminder that for all our certainty, the universe still holds cards it hasn't shown us, and somewhere in the chaos of this defiant cluster, there might be clues to a truth far stranger than we've dared to imagine. HD 140,283, nicknamed the Methuselah star, is one of the oldest known objects in the universe, but its true mystery lies in the bizarre behavior of light in its vicinity. Here, the cosmic speed limit isn't just broken, it flickers like a faulty traffic light. Probes sent to study this ancient stellar relic report signals that sometimes crawl at a fraction of light speed, then suddenly accelerate beyond what Einstein's equations allow. It's as if the star is surrounded by invisible speed traps and cosmic highways that rewrite the rules of the road without warning. What makes this anomaly so disruptive isn't just the fluctuating speeds, it's the precision with which we've measured them. The star's light arrives at Earth with telltale inconsistencies. Normally, photons from distant stars travel at a predictable 299,792 kilometers per second. Yet HD 140,283 light shows variations of up to 0.003%, a tiny number with massive implications. That's like discovering that every Olympic sprinter runs the 100-meter dash in 9.58 seconds, except for one who inexplicably finishes in 9.57 one day and 9.59 the next. The difference seems trivial until you realize it violates the foundational assumption that light speed is an unwavering constant. Theories attempting to explain this phenomenon range from the meticulous to the mind-bending. One camp suggests the star might be entangled with a quantum vacuum fluctuation, a temporary wrinkle in spacetime that alters light's properties as it passes through. Imagine a marathon runner suddenly hitting a stretch of road that's secretly a treadmill. Their speed relative to the ground changes even if their effort remains constant. Similarly, photons here could be interacting with an unseen energy field that effectively resets their velocity. Others propose a more radical idea, that HD 140,283 sits at the edge of a cosmic domain wall, a theoretical boundary where different regions of the universe have slightly different physical constants. Picture a vast patchwork quilt where each square has its own unique gravitational pull or electromagnetic strength. If our local region of space has one value for light speed while the star's neighborhood has another, the fluctuations might reflect photons crossing this invisible frontier. Then there's the tantalizing possibility that we're witnessing light decay. Just as radioactive particles break down over time, some models suggest photons might gradually lose energy across billions of years, not by slowing down, but by undergoing subtle quantum shifts that affect their apparent speed. If true, this ancient star's light could be carrying clues about the universe's ultimate fate encoded in its inconsistent travel time. Yet the most unsettling implication isn't about HD 140,283 itself. It's about the fabric of reality. If light speed isn't perfectly constant everywhere, entire chapters of modern physics might need revision. GPS satellites, particle accelerators, even our understanding of the Big Bang all rely on light speed as a fixed yardstick. What happens to cosmology if that yardstick keeps changing lengths? The answer might rewrite not just textbooks, but our very conception of the universe's architecture. This stellar oddity forces us to confront an uncomfortable truth. The laws we consider universal might be more like local ordinances, varying from one cosmic neighborhood to another. And somewhere in the flickering light of this ancient star, there could be clues to a physics far stranger than we've ever imagined. And you see, 6,240 isn't just two galaxies colliding. It's a cosmic demolition derby where the wreckage has punched a hole in reality itself. Imagine two speeding freight trains crashing head-on, but instead of twisted metal, the impact leaves behind a gaping tear in the fabric of space-time. This isn't theoretical physics. It's a violent, observable event where the laws of the universe fray at the edges. Strange energies bleed through this rift, warping matter in ways that defy explanation. Atoms exposed to these energies gain and lose mass unpredictably, as if the universe can't decide what rules apply here. Light passing near the rift doesn't just bend, it fractures into colors unseen in nature, as if the spectrum itself has been rewritten. What makes this phenomenon so unnerving isn't just the rift's existence, it's the way it behaves. Most cosmic structures evolve over millennia, but NGC 6240 tier fluctuates wildly, sometimes stretching across light years, other times contracting to a pinprick. It's as if something on the other side is testing the boundaries, probing for weak spots. Radiation measurements reveal particles emerging with properties that don't match any known matter or antimatter. Instead, they seem to belong to an entirely different periodic table, one where elements obey alien chemistry. Some exhibit half-lives millions of times longer or shorter than their counterparts in our universe, suggesting the fundamental forces governing their reality operate at different strengths. Theories about what lies beyond the rift range from cautiously scientific to spine-chilling. One camp argues it's a gateway to a baby universe, a fledgling reality budding off from our own like a cosmic seed. In this scenario, the strange energies are the equivalent of amniotic fluid, carrying the building blocks of a new spacetime. Others propose it's a tunnel to a higher dimension, a realm where what we perceive as three-dimensional space is just a shadow of deeper, more complex geometries. There's even a fringe hypothesis that the rift isn't natural at all, that its precise location at the collision point of two galactic cores hints at an engineered structure, a cosmic emergency exit left behind by some ancient civilization. Yet the rift's most unsettling property might be its apparent selectivity. Certain wavelengths of light pass through unimpeded, while others vanish entirely, as if filtered by an invisible intelligence. Radio telescopes have detected rhythmic pulses emanating from the tier, not random noise, but repeating patterns spaced at precise intervals. They match no known astrophysical process, yet bear an eerie resemblance to error correction codes used in human digital communications. It's enough to make even hardened scientists pause. Are these pulses a natural phenomenon or something far more unsettling? The dimensional rift of NGC 6240 forces us to confront a profound question. Could cosmic collisions be more than just destructive events? Might they also be creative forces, forging bridges between realities we've yet to comprehend? As we peer into this celestial wound, one thing becomes clear: the universe doesn't just contain mysteries. It is mystery shaped by forces we're only beginning to glimpse. In the heart of galaxy cluster Max J 1149 plus 2223, the universe plays a cruel magic trick on light, stretching it, splitting it, and sometimes showing it things that don't exist yet. This isn't just gravitational lensing, where massive objects bend light like a funhouse mirror. Here, the distortion is so extreme that single galaxies appear in 5, 6, even 7 identical copies scattered across the sky like shards of a broken hologram. But the real shock comes when astronomers compare these duplicates and realize some show scenes that haven't occurred in our timeline. One image might depict a stable star, while its twin, taking a slightly longer path around the lensing cluster, shows that same star as a supernova years before it's supposed to explode. What makes this cosmic mirage so unsettling is the precision of its illusions. Normally, lensed images are delayed by mere days or weeks due to light's different travel paths. But here, the delays span years, sometimes decades, as if spacetime itself has developed a buffering glitch. The most famous example is supernova Ref Stahl, which appeared in one lensed image in 1997, then showed up again in 2015 right on schedule, as if the universe had leaked spoilers 18 years early. It's like watching a movie where the same scene plays on 2 screens, one showing the beginning, the other the dramatic climax, out of order. The leading explanation involves the cluster's unprecedented mass distribution. Dark matter weaves through max J 1149 plus 2223 in dense, intricate filaments, creating a gravitational lens so complex it behaves like a quantum computer for light processing photons through countless possible paths simultaneously. Some paths are so warped they act as time machines, letting us peek around spacetime's corners. Yet even this doesn't fully explain the phantom images, reflections that depict events that never come to pass in our observations. One duplicate galaxy showed spiral arms perfectly intact, while its counterpart revealed those same arms shredded by a collision that, according to all subsequent data, never occurred. Could this be evidence of branching timelines? Some interpretations of quantum mechanics suggest every decision spawns parallel universes, and max J 1149's lensing might be giving us accidental cross-views into these alternate realities. Alternatively, the cluster might sit at a kink in spacetime where cause and effect get tangled, like a scratched DVD skipping between possible futures. The most haunting possibility: these mirages aren't glitches at all, but deliberate signals, a cosmic SOS showing us every possible fate at once, as if the universe is trying to warn us about paths not taken. What we do know is this: when you stare into max J 1149 plus 2223, the universe stares back not with one face, but with many, some smiling, some screaming, all whispering the same unsettling truth. Time may not flow the way we think, and the future might already be written in light we're only now learning to read. SGR 1800620 isn't just a Magnetar. It's a cosmic monster wielding magnetic forces so brutal they rewrite the rules of physics. Picture a magnetic field 10 quadrillion times stronger than Earth's, so intense it can rip atoms apart from thousands of kilometers away. Metals don't just melt here, they vaporize into swirling plasma clouds, their electrons torn free like petals in a hurricane. Compasses near this stellar beast wouldn't just spin helplessly, their needles would shatter under the strain, reduced to dust by forces that treat the very concept of north as a joke. What makes this Magnetar so terrifying isn't just its power, it's how that power manifests. Normally, magnetism operates on scales we can comprehend, from refrigerator magnets to hospital MRI machines. But SGR 1800620 cranks everything to 11. Its magnetic field warps the quantum vacuum itself, the empty space between particles, creating bizarre quantum effects normally seen only in particle accelerators. Electrons here don't orbit atoms, they spiral in chaotic, jagged paths, as if space itself has developed a stutter. Protons and neutrons inside atomic nuclei distort into oblong shapes, like balloons squeezed by invisible hands. Even light passing through this region gets polarized into strange, corkscrew patterns never observed elsewhere in nature. Then there are the Starquake's violent ruptures in the Magnetar's crust that release bursts of energy so powerful they've been detected across the galaxy. In 2004, a single quake from SGR 1800620 unleashed more energy in a tenth of a second than our Sun emits in 150,000 years. The resulting gamma-ray flash ionized Earth's upper atmosphere from 50,000 light-years away, temporarily disrupting radio communications worldwide. It's as if this distant star reached across the cosmos and flicked our planet with a celestial finger. Yet the greatest mystery lies in how such extreme magnetism even exists. According to conventional astrophysics, magnetic fields this strong should tear the star apart instantly. Yet SGR 1800620 persists, spinning once every 7 seconds despite forces that should have shredded it eons ago. Some theorists speculate its core might contain exotic matter, quark-gluon plasma, or strange elements whose unique properties somehow stabilize the unimaginable pressures. Others suggest we're seeing evidence of a fifth fundamental force, one that only activates under extreme magnetic conditions beyond anything replicable on Earth. Perhaps most unsettling is what this Magnetar implies about the universe's potential for violence. If such objects exist, could there be regions where magnetism grows even stronger, strong enough to unravel spacetime itself? And if human technology ever harnessed even a fraction of this power, would we be holding the keys to limitless energy or unlocking a Pandora's box of cosmic destruction? SGR 18620 doesn't just defy our understanding of magnetism. It forces us to confront how little we truly know about the forces shaping reality. Right now, as you watch this, an invisible tsunami is crashing through our galaxy, a hurricane of dark matter so vast it could swallow star systems whole. Unlike the dark matter that quietly hugs galaxies like ours, this rogue wave isn't playing by the rules. It barrels through the Milky Way at 500 kilometers per second, bending starlight and yanking planets off their orbits without leaving a single visible trace. Astronomers call it the dark matter hurricane, but it behaves more like a cosmic wrecking ball, swinging through space with enough force to rewrite the sky. What makes this phenomenon so eerie is how it betrays its presence. Stars that should glide smoothly through their orbits suddenly stagger like drunks, their paths kinked by something we can't see. Entire solar systems caught in the storm's wake experience bizarre gravitational shudders, planets wobble on their axes, comets get yanked onto wild new trajectories, and asteroid belts ripple like disturbed pond water. Yet when telescopes point at these regions, they show nothing. No dust clouds, no rogue black holes, just empty space behaving as if haunted by an unseen hand. The hurricane's origins are just as mysterious. Most dark matter moves in predictable halos around galaxies, but this maelstrom seems to be a leftover from an ancient cosmic collision. A shredded dwarf galaxy perhaps, whose stars were torn away eons ago, leaving only its dark matter skeleton hurtling through space. Simulations suggest it might be part of the sausage stream, a remnant of a smaller galaxy the Milky Way cannibalized billions of years ago. If true, we're witnessing a ghostly echo of that violence, a shadow of the carnage still rippling through our galactic neighborhood. Then there's the storm's sheer scale, stretching over 30,000 light-years. It's not some localized disturbance, it's a continent-sized upheaval in the fabric of our galaxy. At its core, the density of dark matter might be 1,000 times higher than normal, creating gravitational whirlpools so intense they briefly warp spacetime itself. Satellites like Gaia have detected stars accelerating in ways that defy all known models, as if space itself has developed sudden, invisible hills and valleys beneath their feet. Yet for all its chaos, this hurricane could be a golden opportunity. Dark matter famously refuses to interact with normal matter except through gravity, making it nearly impossible to study directly. But here, in this turbulent zone, its effects are so pronounced that scientists might finally catch it in the act. Detectors buried deep underground are tuning their instruments to the storm's predicted path, hoping to catch the faintest whisper of a dark matter particle colliding with ordinary atoms. Others are scouring the distorted orbits of stars for clues about how this invisible substance behaves en masse, whether it clumps, swirls, or fractures under its own immense forces. The implications stretch far beyond physics. If dark matter can gather into such violent, concentrated storms, it might reshape our understanding of galaxy formation. Perhaps these hurricanes are cosmic sculptors, their unseen forces carving channels through which stars and gas flow, invisibly guiding the evolution of the universe. Or maybe they're harbingers of something darker, proof that dark matter isn't the placid, uniform stuff we assumed, but a turbulent, unpredictable force that could one day send a storm our way powerful enough to fling Earth into the void. One thing's certain, as this silent tempest rages through our galaxy, it's forcing us to confront how little we truly know about the invisible 85% of the universe's matter. The stars may be the Milky Way's glittering jewels, but it's the darkness between them, wild, restless, and utterly mysterious, that holds the real power. The Boötes void isn't just empty space, it's a cosmic cathedral where the whispers of creation itself still linger. Spanning over 300 million light-years, this staggering emptiness is so vast that if our Milky Way sat at its center, the next galaxy would be nearly as distant as the edge of the observable universe. Yet within this desolation lies an eerie phenomenon, sound waves from the Big Bang, trapped like echoes in a grand celestial canyon, repeating their primordial song across billions of years. These aren't ordinary sound waves, their pressure ripples from the universe's violent birth, oscillations so deep and slow that a single wavelength could stretch from Earth to the Andromeda Galaxy and back. What makes these echoes so extraordinary is how they've survived. Normally, sound dissipates quickly in space without air molecules to carry vibrations, waves fade into silence. But in the Boötes void, these ancient vibrations were imprinted onto the fabric of spacetime itself during the universe's first microseconds, when everything was compressed into a seething quark-gluon plasma. As the cosmos expanded, these acoustic signatures froze into the distribution of matter, leaving behind a faint but detectable rhythm. Today, that rhythm manifests as an inexplicable pattern in the void's cosmic microwave background. The afterglow of the Big Bang, where temperature fluctuations align in concentric rings, like ripples from a stone dropped into a pond 14 billion years ago. Decoding these echoes could rewrite physics as we know it. The patterns don't match predictions from standard cosmology. Their frequencies suggest the early universe may have been filled with unknown particles or forces. Some theorists propose these vibrations are evidence of cosmic strings, filaments of pure energy from the Big Bang that vibrated like guitar strings, plucking spacetime itself. Others speculate the void acts as a resonance chamber for actions, hypothetical particles that might constitute dark matter. Then there's the most radical idea that these echoes aren't just remnants of our universe's birth, but interference patterns from collisions with other universes in the multiverse, their gravitational waves leaving faint fingerprints in the void's emptiness. Yet the Boötes void's greatest mystery isn't just what these sounds reveal, it's why they've persisted here and nowhere else. Most of the universe is littered with galaxies whose gravity scatters and distorts primordial signals. But this void's extreme isolation has preserved its acoustic fossils with freakish clarity, like a desert preserving footprints that rain would erase elsewhere. Radio telescopes tuned to these frequencies detect something even stranger. The echoes aren't fading as they should. Instead, certain harmonics grow stronger over time, as if whatever created them is still resonating from beyond the observable universe. Could this be the universe's way of encoding its own origin story? The vibrations spacing hints at dimensions beyond the four we experience, while their amplitude suggests energies far exceeding anything achievable in particle colliders. There's even a haunting mathematical beauty to their structure. The ratios between frequencies match sacred geometry found in everything from atomic orbitals to spiral galaxies, as if the void is humming the fundamental code of reality. As scientists develop new tools to listen deeper, one thing becomes clear: the Boötes void isn't empty at all. It's a sanctuary for echoes older than stars, a place where the universe's first cries still reverberate, waiting for us to decipher their secrets. And in their rhythms, we might just find the keys to understanding everything, from the nature of dark matter to the ultimate fate of spacetime itself. At the heart of the Crab Nebula, a monstrous whirlpool of plasma spins faster than any earthly tornado, so fast it defies the laws of classical physics. This isn't just a swirling cloud of charged particles. It's a cosmic engine accelerating matter to 99.9% the speed of light, whipping electrons into frenzied spirals that emit radiation powerful enough to sterilize planets light years away. The sheer violence of this storm bends the very definition of natural phenomenon, challenging our understanding of how energy behaves in the universe's most extreme environments. What makes this plasma tornado so extraordinary isn't just its speed. It's the way it behaves like a celestial particle collider, but one built by nature itself. In laboratories like CERN, scientists spend billions to accelerate particles in controlled rings. Yet here, in the wreckage of a supernova that exploded nearly 1,000 years ago, the same process unfolds spontaneously across trillions of kilometers. Electrons caught in the storm's grip emit synchrotron radiation, light so intense it outshines entire galaxies, pulsing 30 times per second like a cosmic lighthouse with beams that can be seen across the electromagnetic spectrum. Even more bizarre, the tornado's magnetic field, which measures over 10,000 Gauss, strong enough to reprogram the genetic structure of any living thing that ventured too close. Theories about its origins range from the catastrophic to the uncanny. Most astrophysicists agree the tornado formed from the collapsed core of the original star, its rotation amplified to ludicrous speeds during the supernova like a figure skater pulling their arms in. But some observations don't fit this tidy explanation. The plasma's inner filaments move in perfect harmonic oscillations, as if guided by some unseen force, while its outer tendrils exhibit fractal patterns repeating geometric shapes found in everything from snowflakes to galaxy clusters. This has led to speculative but tantalizing ideas. Could the tornado be tapping into zero-point energy, the quantum fluctuations of empty space itself? Or might it be interacting with dark matter filaments threading through the nebula, using their invisible scaffolding to maintain its impossible structure? Then there's the radiation. The Crab Nebula's gamma-ray flares are among the most energetic events ever recorded, sometimes doubling in brightness within hours for no discernible reason. During these outbursts, detectors have picked up particles with energies exceeding 100 tera-electronvolts, 1,000,000 times more powerful than medical X-rays. If such a flare occurred within a few light years of Earth, it could strip away our ozone layer in days. The fact that this happens routinely in the nebula suggests the plasma tornado isn't just a byproduct of chaos, it's an ongoing factory for high-energy physics, forging particles under conditions we can't replicate anywhere else. Perhaps most unsettling is the tornado's longevity. Normally, such violent structures should dissipate within centuries, their energy bleeding away into space. Yet nearly a millennium after the supernova, the Crab's heart still spins with undiminished fury, as if feeding on some hidden energy source. Some researchers speculate the collapsed neutron star at its center might be converting rotational energy into the storm through quantum processes we don't yet understand. Others wonder if we're witnessing the birth of something entirely new, a previously unknown state of matter that only emerges under these extreme conditions, rewriting the rules of plasma physics in real time. As we peer into this maelstrom, one thing becomes clear: the universe doesn't just create chaos, it weaponizes it, crafting storms that serve as both destroyers and crucibles, obliterating old forms while forging new ones. The plasma tornado of the Crab Nebula isn't just a spectacle, it's a classroom, teaching us that the boundaries between natural and unnatural, possible and impossible, are far more fluid than we ever imagined. And somewhere in its whirling depths, there might be clues to harnessing energies that could power civilizations or unravel them. Somewhere in the depths of intergalactic space, a force so immense pulls thousands of galaxies toward it, yet no one knows what it truly is. The Great Attractor isn't just a mystery, it's a cosmic hall of mirrors where reality itself seems to glitch. Here, at the heart of this gravitational behemoth, the universe behaves like a malfunctioning hologram. Galaxies billions of light-years away appear startlingly close, as if space has folded in on itself. Time fractures into nonsensical fragments. Observers report events repeating out of sequence or vanishing from telescopic data entirely, like scenes deleted from a film reel. It's as if we're not just looking at the cosmos here, but at its source code, and someone forgot to render the details properly. What makes this phenomenon so unsettling is the precision of its distortions. Normally, gravitational lensing bends light predictably, like viewing objects through a glass of water. But in the Great Attractor's vicinity, the effect is jagged and inconsistent. One galaxy might appear stretched like taffy, while its neighbor looks perfectly normal. Some objects duplicate like digital artifacts in a corrupted video file, their light taking multiple contradictory paths to reach us. Even more bizarre are the time anomalies. Astronomers have detected supernova flaring up in this region weeks before their light should have reached Earth, as if causality itself has developed a buffering delay. The leading theory suggests we're glimpsing evidence of a holographic universe. Just as a two-dimensional DVD holds all the information needed to project a three-dimensional movie, some physicists propose that our three-dimensional reality might be encoded on a distant two-dimensional surface, and the Great Attractor could be where that projection frays at the edges. In this model, the strange visual artifacts aren't glitches but pixels showing through, brief moments where the resolution of reality dips low enough to reveal the scaffolding beneath. Mathematical models show that the anomalies align suspiciously well with what you'd expect from a universe rendered in real time, with the Great Attractor serving as a kind of cosmic graphics card struggling to process too much information at once. Yet there's another, even wilder possibility, that this region isn't part of the simulation, but a backdoor left by its creators. The Great Attractor's gravitational pull is so strong that entire galaxy clusters stream toward it in a river of stars, including our own Milky Way, moving at over 2 million kilometers per hour. Some have speculated that this could be intentional design, a reset point where the universe periodically gathers its data for maintenance or observation. It sounds like science fiction until you consider that the mathematical equations describing quantum mechanics often resemble code more than physical laws, with observer-dependent outcomes that eerily mirror video game rendering techniques. Whatever the truth, the holographic horizon forces us to confront a humbling idea: that the universe might not just contain mysteries, but be a puzzle wrapped in space-time, with the Great Attractor as its most tantalizing piece. As we fall toward it at incomprehensible speeds, we might not just be approaching a gravitational anomaly, but the edge of reality's screen. And when we finally reach it, will we find the projector? Or simply the off switch? SN 1987A should be invisible at least. That's what physics textbooks would tell you. When this star exploded in 1987, it unleashed a storm of neutrinos so vast that trillions passed through every human on Earth in the blink of an eye. These ghostly particles, so ethereal they rarely interact with matter, slipped through our planet as if it weren't even there. Yet in the swirling wreckage of this supernova remnant, something impossible is happening. Neutrinos are stopping. Not just slowing down clustering, gathering mass, and forming eerie, unstable structures that glow faintly in the wreckage like cosmic will-o'-the-wisps. It's as if the universe flicked a switch and turned these spectral particles into something tangible, rewriting the rules of particle physics in real time. What makes this neutrino storm so extraordinary isn't just the particles' sudden heft, it's the way they behave afterward. Normally, neutrinos with mass should decay almost instantly, vanishing back into the quantum foam. But here they linger, twisting into braids and knots that pulse with weak nuclear energy. Some formations resemble atomic nuclei, but with bizarre, impossible shapes: tetrahedrons, spirals, even Mobius strips made purely of neutrinos. Others flicker in and out of visibility, as if straddling the boundary between our universe and another. The most striking feature: these structures emit a unique signature of radiation that matches nothing in known physics, a frequency so peculiar it's been dubbed dark light by baffled researchers. The implications for dark matter are staggering. For decades, scientists have hunted for this invisible substance, which outweighs normal matter 5-to-1 yet refuses to interact with light. Neutrinos were always a long-shot candidate, too lightweight and fast-moving to explain dark matter's gravitational grip on galaxies. But SN 1987A's transformed neutrinos tell a different story. Their sudden mass gain suggests they might be interacting with an unseen field or particle, something that briefly anchors them in our reality. Imagine tossing a handful of feathers into a hurricane. Normally, they'd scatter instantly. But if the storm had hidden pockets of static charge, those feathers might cling together in strange, fleeting shapes. That's the kind of phenomenon we're witnessing here, but on a subatomic scale. Could this be the key to unlocking dark matter's secrets? Some theorists propose the supernova's shockwaves triggered a phase transition in the neutrinos, momentarily exposing them to a hidden dimension where they acquire mass. Others speculate that SN 1987A's core might contain relics of the early universe particles called sterile neutrinos, long hypothesized as dark matter candidates but never observed. The most radical idea: that we're seeing neutrinos entangled with their own counterparts from parallel universes, creating hybrid particles that briefly freeze into detectable forms before vanishing again. Yet the most tantalizing clue lies in the timing. The neutrino clusters pulse rhythmically, their brightness swelling and fading in sync with gravitational waves detected from the same region. It's as if the supernova remnant is humming a tune written in the language of both particle physics and spacetime itself. If neutrinos and gravity are dancing together here, it might hint at a grand unification, a theory connecting quantum mechanics and relativity, the holy grail of modern physics. SN 1987A's ghostly storm forces us to confront a humbling truth. Even the most elusive particles in the universe might have hidden depths, and somewhere in this celestial blizzard, neutrinos once thought to be mere cosmic background noise could be whispering the secrets of dark matter itself. The question isn't just why they've gained mass here, but what else they're trying to tell us about the invisible scaffolding of reality. Stretching across the cosmos like an invisible wire, the cosmic string near 1ES 2344 + 514 defies every intuition about how matter should behave. This isn't just some wispy trail of energy, it's a scar from the universe's birth, a flaw in spacetime so dense that a single segment the length of a pencil could outweigh Mount Everest. Picture a thread thinner than a proton, yet massive enough to warp passing starlight into eerie double images, as if space itself has developed a crack. And the most unsettling part, these strings might be everywhere, weaving through the cosmos like invisible spider silk, waiting to be stumbled upon. What makes this cosmic string so extraordinary isn't just its existence, it's how it moves. Unlike stationary black holes or drifting nebulae, this filament vibrates at frequencies that send shockwaves through spacetime. Astronomers have detected gravitational ripples emanating from its vicinity, subtle tremors that don't match any known celestial event. It's as if the string is plucking the fabric of reality like a guitar string, producing notes too low for human ears but powerful enough to nudge galaxies off course. Some models suggest these vibrations could even create closed time-like loops, regions where time folds back on itself, allowing hypothetical observers to glimpse their own past. Theories about its origins split into two camps. One argues it's a fossil from the Big Bang, a frozen defect formed when the newborn universe underwent a phase transition, like ice crystals cracking as water freezes. In this scenario, cosmic strings are the jagged edges where spacetime didn't smooth out properly, relics of a time before the laws of physics settled into their current form. The other camp proposes something far stranger, that this string isn't a remnant but an active fault line, a place where two distinct regions of spacetime stitched together imperfectly after a collision between parallel universes. Imagine two soap bubbles merging, their surfaces fusing along a taut, quivering seam. That's the kind of cosmic surgery we might be witnessing. Then there's the string's eerie ability to mimic other phenomena. Its gravitational lensing effects resemble those of dark matter, raising the provocative idea that some dark matter halos enveloping galaxies might actually be tangled nests of these filaments. Its energy emissions occasionally mirror pulsar signals, fooling astronomers into thinking they've discovered a new neutron star. Even its vibrations produce harmonics that match unexplained background hums in gravitational wave detectors. It's as if the universe keeps using this one bizarre object to impersonate half its other mysteries. Yet the most tantalizing possibility is what the string implies about the universe's structure. If such filaments exist, they might form an invisible lattice guiding the large-scale arrangement of galaxies, like unseen rails steering cosmic traffic. Simulations suggest that if multiple strings crossed, their intersections could spawn primordial black holes, or worse, trigger spontaneous vacuum decay, where a single rupture in spacetime catastrophically expands at light speed, rewriting the laws of physics in its wake. It's a cosmic game of Russian roulette where the strings are both the bullets and the barrel. As we study this thread of pure energy, one thing becomes clear: the universe isn't just stranger than we imagine, it's stranger than we can imagine. And somewhere in the vibrations of this cosmic string, there might be clues to realities beyond our own, hidden in frequencies we're only beginning to hear. Deep within the supernova remnant W49b, matter doesn't just exist, it pulses, beating like a cosmic heart in rhythms that defy time itself. These aren't ordinary structures, they're time crystals, a form of matter so bizarre it repeats its atomic arrangement not in space, but in time, cycling through configurations like a flipbook of reality. Imagine a snowflake that melts and refreezes in perfect sync with an unseen cosmic metronome, never losing energy, never slowing down, as if the universe hit pause on entropy itself. That's the eerie beauty of W49b, a place where the laws of thermodynamics seem to have been put on hold. What makes these time crystals so revolutionary isn't just their defiance of decay, it's how they form. Normally, perpetual motion is impossible, friction and entropy always win. But here, in the turbulent aftermath of a star's violent death, conditions align in a way that locks matter into quantum grooves. Atoms arrange themselves into patterns that must repeat, bound not by chemical bonds but by the fundamental symmetries of spacetime. It's as if the supernova's shockwaves carved microscopic wells in the fabric of reality, and particles now roll through them like marbles in a never-ending track. The implications for energy are staggering. Time crystals don't just resist entropy, they sidestep it entirely, their oscillations continuing indefinitely without any external input. In theory, if we could harness this phenomenon, it might open the door to machines that never wind down, quantum computers that never decohere, or even, dare we dream, energy systems that require no fuel. But there's a catch. W49b's time crystals exist only under extreme conditions, their delicate dance easily disrupted by the slightest temperature change or magnetic interference. It's like discovering a fire that burns without consuming its fuel, only to realize it can't survive outside a vacuum. Yet the nebula's true mystery lies in the scale of these structures. While human-made time crystals in labs are microscopic, W49b's span light years, their rhythmic patterns visible in the pulsing glow of ionized gases. Some regions flicker with clockwork precision, emitting bursts of X-rays every 1.2 seconds like celestial pendulums. Others exhibit fractal harmonies, where smaller crystals nest inside larger ones, all beating in sync like gears in a cosmic watch. This isn't just quantum weirdness, it's quantum organization on a galactic scale, suggesting that time crystals might be more than a curiosity. They could be a fundamental feature of the universe's architecture. Then there's the haunting possibility that these crystals aren't natural at all. The supernova's remnants contain odd isotopic ratios, elements like nickel-60, in abundances that don't match typical stellar nucleosynthesis. Some theorists speculate that a highly advanced civilization might have engineered these time crystals as a form of energy storage or communication, leaving behind a self-sustaining beacon in the wreckage of their star. Others argue it's evidence of a deeper physics, that time itself may have granular, crystalline properties at cosmic scales, with W49b offering a rare glimpse into time's atomic structure. As we study this nebula's impossible rhythms, one thing becomes clear. The universe doesn't just follow rules, it invents them. And somewhere in the heartbeat of W49b, time itself might be whispering secrets about realities where energy is infinite, decay is optional, and the arrow of time is just another spiral in an endless cosmic dance. RXJ 1131-1231 doesn't just defy the laws of physics, it taunts them. This cosmic phantom lurks in the void, yanking stars and galaxies toward its unseen grip while revealing nothing of itself. No event horizon, no accretion disk, not even the faintest whisper of radiation. It's as if gravity itself has gone rogue here, warping spacetime without the courtesy of a black hole's usual calling cards. Astronomers call it a naked singularity, a gravitational monster stripped of its shroud, a place where the universe's rules don't just bend, they vanish entirely. What makes this phantom gravity well so unnerving is how it violates the cosmic order. Black holes, no matter how mysterious, at least follow some rules. They cloak their singularities behind event horizons, the ultimate, no trespassing signs where even light can't escape. But RXJ 1131-1231, it's all singularity, no curtain. Matter spiraling toward it doesn't vanish from view. It stretches and distorts in plain sight, like taffy pulled toward an invisible mouth. The effect is so extreme that background galaxies behind it appear smeared across the sky, their light bent into grotesque arcs by gravity's bare fist. Theories about what lies at its core range from the mind bending to the existential. Some physicists argue we're seeing a failed black hole, a singularity that somehow skipped the step of forming an event horizon, like a fire burning without smoke. Others propose it's a portal to a higher dimension where gravity leaks into our universe through a crack in spacetime's fabric. the most radical idea. That this isn't a singularity at all, but a knot of dark energy so dense it mimics one, warping reality not by crushing matter but by unraveling the very vacuum of space. Then there's the fate of anything unlucky enough to fall in. Normally, matter crossing a black hole's event horizon is lost forever, its information scrambled beyond recovery. But here, with no horizon to hide behind, physicists can't even agree on whether objects would be torn apart, crushed to infinite density, or most unsettlingly, spit back out elsewhere in the cosmos, rewritten by forces beyond our comprehension. It's like watching a cosmic garbage disposal with no bottom. Stuff goes in, but nobody knows where or in what form it might emerge. The implications ripple far beyond this one anomaly. If naked singularities exist, they might rewrite our understanding of causality. Without an event horizon to enforce order, cause and effect could tangle like earbuds in a pocket, allowing paradoxes where events precede their own triggers. Even more unsettling, if singularities can exist uncovered, the universe might be littered with them, invisible, unpredictable, and utterly indifferent to the laws we once thought governed all of reality. As we stare into this gravitational enigma, one thing becomes clear. RXJ 1131-1231 isn't just a cosmic oddity. It's a challenge, a dare from the universe to rethink everything we know about the fabric of existence. And somewhere in its invisible depths, the answers might be waiting, or perhaps, like the singularity itself, those answers are naked, hidden in plain sight, if only we know how to look. The Large Magellanic Cloud hides a secret that makes quantum entanglement look child's play, a celestial dance where entire star systems move in perfect, instantaneous sync, as if strung together by invisible threads. This isn't just particles whispering to each other across a lab bench. It's constellations separated by light years acting like parts of a single, sprawling organism. Astronomers first noticed the anomaly when studying binary stars in this satellite galaxy. Twin suns locked in orbit, their spins perfectly mirrored despite no visible force connecting them. Then came the real shock, nebulae light years apart flaring in unison, their energy bursts matching down to the millisecond, defying the cosmic speed limit set by light itself. What makes this entanglement nexus so revolutionary is the sheer scale of the phenomenon. On Earth, quantum entanglement links particles no farther apart than a few kilometers, their bond fragile as a soap bubble. But here, the quantum connection spans thousands of trillions of kilometers, weaving through dust clouds and star clusters with eerie precision. It's as if the universe has stitched this corner of space together with quantum thread, creating a tapestry where every knot tugs on every other, no matter the distance. The math suggests something even stranger. These connections might not follow the usual rules of decay over distance. Instead, they grow stronger with separation, like tension in a cosmic rubber band stretched to its limit. Theories about the nexus range from the poetic to the paradigm-shattering. One camp argues we're seeing evidence of a quantum foam, a frothy, subatomic structure theorized to underpin spacetime stretching and warping on galactic scales. In this view, the Large Magellanic Cloud sits at a rare knot in this foam, where quantum connections amplify instead of dissipating. Others propose a radical twist, that dark matter acts as a quantum relay, its invisible particles serving as intermediaries that entangle ordinary matter across vast distances. Then there's the most mind-bending idea that this region is a literal cosmic computer, with entangled stars serving as qubits in a celestial calculation we can't yet decipher. Yet the most tantalizing clues come from the nexus's imperfections. Not everything here is entangled. Certain star systems resist the connection like rebels in a synchronized dance. These outliers share a curious trait: unusually high concentrations of heavy elements like gold and platinum, metals forged in violent stellar collisions. It's as if cosmic trauma, supernova, or neutron star mergers can sever these quantum threads, leaving behind scars in the form of precious metals. This discovery has sent materials scientists into a frenzy, with some speculating that quantum-entangled alloys might exist naturally here, their atomic structures linked across space in ways that could revolutionize technology. The implications ripple far beyond astrophysics. If entanglement can scale to such magnitudes, it might explain mysteries like dark flow, the unexplained motion of galaxy clusters toward a single point in space. Perhaps the universe is far more interconnected than we imagined, with hidden quantum networks guiding large-scale structure. Or maybe, just maybe, we're glimpsing the universe's source code, a fundamental layer where distance is an illusion and everything is written in the language of entanglement. One thing's certain: the Large Magellanic Cloud isn't just a neighbor galaxy. It's a looking glass showing us a reality far stranger and far more connected than we ever dared to dream. Gleezer 436b isn't just another exoplanet, it's a cosmic paradox where fire and ice wage an endless war, defying everything we know about the states of matter. Imagine a world where glaciers don't melt, even as they're scorched by temperatures hot enough to vaporize steel. Here, water exists as burning ice, a form so densely compressed by the planet's crushing gravity that it stays solid at a blistering 400 degrees Celsius. This isn't science fiction, it's a real-world laboratory for physics gone wild, where the ordinary rules of chemistry twist into knots. What makes this ice so bizarre isn't just its heat resistance, it's the way it defies molecular logic. On Earth, water molecules under high pressure form familiar ice variants like the hexagonal crystals in your freezer or the denser ice Roman III found in deep ocean trenches. But Gleezer 436b's version, dubbed Ice X, is something else entirely. Its oxygen atoms lock into a cubic lattice so tight that hydrogen atoms float freely between them, creating a surreal hybrid of solid and supersonic states. Picture a diamond that conducts electricity like a metal, or a block of ice that flows like molasses without ever truly liquefying. This is matter rewritten, a phase that exists only under pressures 1,000,000 times greater than Earth's atmosphere, where the very concept of solid blurs into something alien. The planet itself is a study in extremes. Orbiting dangerously close to its red dwarf star, Gleezer 436b's surface is a hellscape of searing winds and gravitational tides so strong they've sculpted its core into a lopsided football-like shape. Yet beneath its blazing atmosphere lies that surreal icy mantle, not floating in water but suspended in a plasma-like state, shimmering with pent-up energy. The ice doesn't just persist, it thrives, its crystalline structure growing stronger as temperatures rise, like a candle that hardens in flame instead of melting. Scientists suspect this exotic ice might be just the tip of the iceberg, literally. Deeper still, pressures could squeeze matter into even stranger forms, metallic hydrogen, degenerate matter, or phases so novel they lack names. Some models suggest the ice transitions into a superfluid near the core, a frictionless ocean that generates the planet's bizarre magnetic field, which wobbles unpredictably like a compass needle near a thunderstorm. Yet the greatest mystery isn't what Gleezer 436b is made of, it's how it reshapes our understanding of habitability. If ice can exist in such infernal conditions, what other impossible states might lurk on distant worlds? Could there be planets with molten diamonds or oceans of liquid quartz? This exoplanet forces us to confront a humbling truth. The universe's palette of matter is far richer and far weirder than our textbooks ever allowed. And somewhere in its burning ice lies a clue to the infinite variety of worlds waiting to be discovered. SS-433 doesn't just defy expectations, it laughs in the face of them. This microquasar, a compact stellar corpse feeding on a companion star, fires twin jets of plasma at nearly a quarter the speed of light. But here's the twist: these jets don't shoot straight like every other quasar in the universe. Instead, they spiral outward in a perfect corkscrew, tracing helical patterns across thousands of light years, as if some cosmic hand is twisting them like ribbons on a maypole. The energy required to bend these relativistic beams would vaporize entire solar systems, yet SS-433 accomplishes it effortlessly, its invisible puppeteer leaving astronomers utterly baffled. What makes this radiation fountain so extraordinary isn't just the jet's curvature, it's their sheer persistence. Most quasars flicker like candles in the wind, their jets sputtering out after a few thousand years. But SS-433 has been firing continuously for over a century, its plasma streams unbroken and unchanging, as if tapped into some infinite well of power. The beams glow with X-rays so intense they've been detected from over 18,000 light-years away, outshining the combined light of every star in their path. Yet the microquasar itself is tiny, barely 25 kilometers across, proof that cosmic violence isn't about size, but about leverage. The leading theory involves a supermassive black hole spinning so fast it drags spacetime around it like a whirlpool. This frame-dragging effect, predicted by Einstein but rarely observed so dramatically, could warp the jets into their eerie spiral. But there's a problem: the math doesn't add up. The black hole would need to spin faster than physics allows, approaching a state where time itself would distort into loops. Some researchers speculate the answer lies in the accretion disk, a swirling maelstrom of superheated gas feeding the black hole. Normally, these disks are flat as vinyl records, but SS-433 is warped into a shape resembling a potato chip, its uneven gravitational tugs yanking the jets off course. Then there's the mystery of the jet's composition. Spectroscopy reveals they're laced with heavy elements like iron and nickel, atoms usually forged in supernova. Yet SS-433 shows no signs of such an explosion. One radical explanation suggests the black hole might be spitting out material from a previous universe, a relic of the Big Bang's cyclic model, where each cosmic iteration leaves traces in the next. Others propose the jets are tunneling through higher dimensions, their curvature an illusion caused by our limited three-dimensional perspective. The most unsettling feature, though, is the jet's synchronization. Despite their mind-bending paths, the twin beams remain perfectly mirrored, their helices matching down to micrometer scales even light-years apart. This coordination defies all known physics. Information can't travel fast enough to keep them aligned. Unless, that is, they're not separate jets at all, but a single unified structure piercing through spacetime like a needle through folded cloth. SS-433 forces us to confront a humbling truth. Even the most violent objects in the cosmos might be following rules we've yet to decipher. And somewhere in those twisting jets, there could be clues to forces that shape not just quasars, but the very fabric of reality itself. The local void should be empty, a vast cosmic desert where galaxies are few and far between. But in this seemingly barren stretch of space, something far stranger is happening. Dark energy, the mysterious force driving the universe's expansion, isn't just working quietly in the background here, it's throwing a tantrum. Imagine a calm river suddenly erupting into violent whirlpools, surging unpredictably as if some unseen hand keeps turning the cosmic faucet on and off. That's the eerie reality of this dark energy storm, where the very fabric of space accelerates outward in fits and starts, stretching and snapping like an overworked rubber band. What makes this phenomenon so unsettling is the wreckage it leaves behind. Galaxies unfortunate enough to drift into this zone don't just drift apart gently. They're torn asunder by invisible tides, their stars scattered into ghostly streamers that glow faintly against the void. These aren't the graceful spiral arms we're used to seeing. They're cosmic crime scenes, the remains of galactic structures shredded by forces we can't see or fully comprehend. Telescopes have captured images of these stellar graveyards, where the gravitational bonds that held galaxies together for billions of years were no match for dark energy's sudden mood swings. Scientists first noticed something was amiss when they measured the velocities of galaxies near the local void. Instead of moving predictably, they lurched outward in sudden bursts, as if space itself was hiccuping beneath them. The expansion rate here fluctuates wildly, sometimes surging 3 times faster than the rest of the universe, other times slowing to a crawl. It's as if this region is a faulty pressure valve in the cosmos, leaking dark energy in erratic pulses that leave astrophysicists scrambling to update their models. The leading theories range from the complex to the downright surreal. One camp suggests the void might be a bubble of lower density space where dark energy's effects are amplified, like a dent in a balloon causing the surrounding rubber to stretch unevenly. Others propose we're seeing the fingerprints of a higher dimensional brain, a parallel universe brushing against ours and warping dark energy's behavior in the process. The most radical idea, that the void isn't empty at all, but filled with an unstable form of dark energy that's decaying into something even more exotic, releasing bursts of energy as it transforms. Yet the most haunting implication isn't just about this one anomaly, it's about what it means for the universe's fate. If dark energy can behave this chaotically here, could other regions eventually follow suit? Could the accelerating expansion of the universe, currently so smooth and uniform, one day become a storm of violent fluctuations, tearing apart structures faster than gravity can hold them together? The local void might be giving us a preview of cosmic oblivion, a glimpse into how the universe could end not with a whimper, but with a series of violent, invisible surges. As we study this dark energy storm, one thing becomes clear: the void isn't empty. It's a cosmic laboratory, showing us just how little we understand about the force that will ultimately decide the fate of all things. And somewhere in its ghostly trails of starlight, there might be clues to the universe's final act, whether it's a slow fade to black or a spectacular, invisible unraveling. Beneath the fabric of reality, at scales so small they make atoms look like planets, lies a seething ocean of pure chaos, the quantum foam of the Planck scale. Picture spacetime not as the smooth, invisible grid we imagine, but as a boiling pot where microscopic bubbles constantly form and pop, each lasting mere fractions of a trillionth of a second. In this frenzied underworld, particles don't just move, they flicker into existence from nothingness, borrowing energy from the future before vanishing again, like fireflies blinking in and out of a pitch-black void. The rules here aren't just different, they're unrecognizable. Distance loses meaning, time stutters like a broken film reel, and the very idea of empty space becomes a joke because nothing is ever truly empty. What makes this quantum foam so radical isn't just its turbulence, it's how it redefines reality's foundation. According to quantum mechanics, these fleeting bubbles aren't defects, they're the universe's raw material. Every cubic centimeter of seemingly tranquil space around you churns with virtual particles, electron-positron pairs, quarks, even miniature black holes, all dancing on the edge of existence. Normally, this frenzy stays hidden, cancelled out by opposing fluctuations, but probe closely enough and the illusion of stability shatters. It's like discovering that a marble floor is actually a trampoline covered in tissue paper. Step too hard and you'll plunge into the chaos beneath. The implications warp the mind. If spacetime is foamy at this scale, then the universe might be pixelated with a fundamental resolution limit beyond which you can't zoom. Think of it as nature's version of a digital image, smooth from afar but jagged when magnified. Some theories suggest this graininess could hold the key to unifying gravity with quantum mechanics, a puzzle that stumped physicists for a century. In this view, gravity isn't a force transmitted through space, but a byproduct of the foam's turbulent geometry, like waves emerging from the churn of the sea. Yet the foam's greatest mystery might be its role in cosmic birth. During the Big Bang, when the universe was smaller than a proton, these quantum fluctuations could have been stretched to astronomical sizes, seeding the galaxies and voids we see today. That means the grand tapestry of the cosmos, every star, every planet, every thread of dark matter might trace back to microscopic bubbles that boiled for less time than it takes light to cross an atom. It's as if the universe began not with a bang, but with a froth, its destiny written in foam. But here's the twist: we may never observe this realm directly. The Planck scale is a quadrillion times smaller than anything our particle colliders can probe, leaving us to piece together its nature through mathematical whispers and indirect clues. Some experiments, like hunting for frothy distortions in light from distant gamma-ray bursts, offer glimmers of hope. Others suggest the foam might leave fingerprints in ultra-precise atomic clocks, their ticks jittering like a needle on a quantum seismograph. The quantum foam forces us to confront a humbling truth. Reality's most fundamental layer isn't solid, stable, or even fully real. It's a seething, probabilistic storm where existence itself is a dice roll, and the ground beneath our feet and the space between the stars is nothing more than the calm eye of an infinite hurricane. KIC 8,462,852 doesn't just flicker. It winks at us like a cosmic conspirator, dimming in ways that defy every textbook explanation. This bizarre star, nicknamed Tabby's star after its discoverer, doesn't follow the predictable rhythms of typical variable stars. Instead, it plunges into sudden, dramatic eclipses, its light sometimes dropping by a staggering 22% before rebounding days or weeks later. That's not just unusual, it's physically implausible. Even a Jupiter-sized planet passing in front of it would only block about 1% of its light. Whatever's causing these dips isn't just big, it's shape-shifting, appearing and disappearing like a celestial phantom. The first theories pointed to a swarm of comets, perhaps a family of icy fragments, so vast they could collectively obscure the star. But calculations quickly dismantled that idea. The energy required to vaporize enough comets to explain the dimming would far exceed what the star emits, creating an infrared glow we simply don't see. Then came the more exotic explanations. A colossal debris field from a planet torn apart by tidal forces, or a warped protoplanetary disk filled with clumps of dust orbiting at bizarre angles. Yet none fully account for the star's long-term behavior, which includes a century-long dimming trend captured in old photographic plates. A fade so gradual it suggests something far more systematic than random debris. This is where the plot thickens and where the whispers of alien megastructures emerge. In 2015, astronomer Jason Wright floated a provocative idea. What if we're seeing the shadows of a Dyson swarm? These hypothetical constructs, first imagined by physicist Freeman Dyson, would be vast arrays of solar collectors built by an advanced civilization to harness their star's energy. Such a structure wouldn't be solid. It'd consist of countless orbiting panels or habitats, creating irregular, asymmetrical shadows, exactly what we observe with KIC 8,462,852. The notion isn't as far-fetched as it sounds. After all, humanity already dreams of building orbital solar farms. Why couldn't a more advanced species have done it first? Yet the star's mysteries don't stop there. Spectroscopic analyses reveal another anomaly. Its light lacks the telltale chemical fingerprints of dust scattering, which should redden its glow like a sunset. Instead, the dimming affects all wavelengths equally, as if the obscuring object is perfectly opaque, more like a solid structure than a cloud of particles. Even stranger, some dips last for days, while others stretch for years, suggesting a phenomenon operating on wildly different timescales. It's as if the star is being toyed with by forces that don't just break the rules, but rewrite them entirely. Perhaps the most unsettling possibility is that we're witnessing a breakdown in astrophysics itself. Some theorists suggest Tabby's star might be consuming planets, its erratic dimming caused by the chaotic infall of planetary debris. Others propose it's trapped in a dense knot of interstellar medium, though no such gas cloud has been detected nearby. Then there's the radical idea that the star's light is being bent by a rogue black hole's gravity, though such an object would leave other detectable traces. With each new observation, the puzzle only deepens, leaving scientists grappling with a truth that's as elusive as it is electrifying. KIC 8,462,852 isn't just a star, it's a mirror reflecting back our own limitations. Whether the answer lies in alien engineering, unknown cosmic phenomena, or physics yet to be discovered, one thing is certain: the universe still holds mysteries that refuse to fit neatly into our models. And somewhere in the flickering light of this enigmatic star, there might be clues waiting to rewrite our place in the cosmos. From quantum vortices to dark energy storms, these 24 unstable realms aren't just cosmic oddities, they're flashing neon signs pointing toward truths we've barely begun to grasp. Imagine the universe as a grand puzzle where every piece we fit reveals 10 more missing, each more bewildering than the last. These regions, where physics unravels and reality rewrites itself, aren't failures of nature. They're its boldest experiments, laboratories operating on scales and timelines we can scarcely comprehend. Take NGC 1277 quantum vortex, where particles teleport like ghosts between dimensions, or the time-dilating abyss near PSRJ 1748-2446 AD, where clocks tick slower as if spacetime itself has grown weary. These aren't just theoretical curiosities, they're proof that the universe has playbooks we haven't found yet. Even something as fundamental as gravity, the force that literally keeps our feet on the ground, becomes a mere suggestion in places like Messier 87 upside-down realm, where objects fall upward and light bends in impossible spirals. What's truly humbling isn't just the existence of these anomalies, it's how they force us to confront the limits of human knowledge. For centuries, we've built scientific models assuming the laws of physics are universal constants. But these cosmic mavericks laugh at such arrogance, showing us that reality might be more like a patchwork quilt, with different rules stitching together different corners of existence. The Neutrino Storm in SN 1987A, where ghostly particles suddenly gain mass, or the holographic horizon of the Great Attractor, where galaxies appear closer than they should, these phenomena whisper a tantalizing question. Are we decoding the universe's operating manual, or just reading one page of an infinite library? This isn't just about satisfying scientific curiosity. Unlocking these mysteries could redefine civilization itself. The time crystals in W49b, pulsing without energy loss, might hold blueprints for perpetual motion machines. The quantum entanglement nexus in the Large Magellanic Cloud could revolutionize communication across interstellar distances. Even the dark energy storm in the local void, terrifying as its galactic shredding may be, might teach us how to harness the very force accelerating the universe's expansion. Yet for all we've discovered, the greatest revelation might be how little we truly know. Every time we point a telescope at these cosmic rebels, they show us something new, something that crumples up our best theories and tosses them into the void. KIC 8,462,852 erratic dimming, the phantom gravity well of RXJ 1131, 1231, the antimatter tempest in IC 1101, each is a reminder that the universe thrives on throwing curveballs. So what's next? The journey certainly doesn't end here. New telescopes like the Vera Rubin Observatory and the James Webb Space Telescope will peer deeper into these enigmas, while quantum computers might simulate conditions we can't yet recreate in labs. Citizen scientists, maybe even some of you watching, could spot the next great anomaly in public data sets. The cosmos isn't done surprising us, and that's the most exhilarating part. If this exploration has sparked your imagination, you're already part of the adventure. Share your wildest theories in the comments. Could dark matter hurricanes explain ancient extinction events? Might time crystals hold the key to immortality? There are no wrong answers when dealing with mysteries this profound. Don't forget to like, subscribe, and hit that notification bell, because the universe has countless more secrets waiting to be uncovered. Until our next cosmic detective story, keep gazing upward and wondering boldly. After all, every great discovery begins with two simple words: